So over the next 2 videos, I'm going to be wiring up all the stepper motors, drivers, spindle, VFD, and showing you how it's done. But don't forget, you're dealing with high-powered electrics here. If you are not electrically minded and you want to have a go yourself, you must have it checked out by a qualified electrician before ever you turn it on. And indeed, you need to check with your local regulator what specific electrical requirements are required in your region. And also don't forget, if you like my videos and like what I'm doing, please like and subscribe to my channel. And if you really like what I'm doing, you could become a patron to my channel, because it's the patrons behind the channel that actually make everything happen around here. So the first wiring we're going to deal with is the spindle. Now, a lot of people have asked me what type of cable to use for the spindle. Well, the spindle is a 3-phase motor. So it has 3 separate windings inside. But you haven't really got to worry too much about that, about as in your power supply, because your VFD, which is the brains that runs the spindle, that is powered by either single phase, which is the normal type power you have in your wall sockets, or 3-phase. It doesn't matter to it, just matters how you connect it up. In the previous video to this, I showed you how to connect the VFD mains power up for a 230 volt system, and the VFD will actually change that single phase power and deliver 3-phase to the spindle. Now then, the cable you require is a 4-core 3-phase cable. Now you can purchase this at any decent electrician outlet. In my case, in Australia, J-Car sell it. And you obviously need the right type of cable. This is 10 amp cable, 3-phase. Now a lot of people ask me, well, how do you work out the ampage, correct ampage cable that you require? Well, I'll show you. So everybody these days has smartphones, and you just pull up your calculator. Now, there's a thing called Ohm's law. Now, Ohm's law is a pretty standard calculation to work out watts and voltage and amps in the electrical, if you're an electrician or if you are doing anything electrical. Now, I'll show you how it works. So in our case, this is 2.2 kilowatt, so that's 2,200 watts. So 2,000, I'll come a bit closer, hopefully you can pick this up. 2,200 watts, okay? Divided by the circuit voltage, which is 230. Now there's your answer, 9.56 amps. Now that's the maximum draw, okay? So maximum power that this can ever draw, and they don't unless you stall them, but I will say that the VFD actually protects the system. The VFD will only allow the maximum ampage that you set it to, okay? So you can't overload the wire or the motor, all right? So this will never actually draw 10 amps. It will, it will never draw it, because it's a high speed, 24,000 RPM maximum, and once it's up to speed and cutting, it's just not going to draw the maximum ampage at all. And in addition to that, it's got what they call a soft start. In other words, it's not, the VFD doesn't switch on and bang, zip, this is straight up there. If you notice with a spindle, they start up quite slowly. They take about 3, 4, 5 seconds. You can actually set the time you wish this to come up to speed as well. So if it was a flicker switch and this came on immediately, then you will get a peak then of ampage draw. But it's all protected. So rabbiting on a bit here now. So there's 4 cables in here and 4 different colors. So what we're going to do now is connect into the motor, and I'm going to show you in detail how to do that. Incidentally, you will need ready flux solder and a soldering iron. You don't rely on crimped electrical connectors for a 3-phase unit. So what I've done is I've peeled back the outer layer of insulation on this 3-phase 4-core cabling for the VFD. Now I won't reveal the wires yet on the end because we've got to get them through the top of here, and sometimes it can make it a little awkward. It makes it fray up and whatever, the copper wires. So we're going to take this cover off now. Okay, so that's what's inside. A little wiring diagram printed on the inside of there. I don't know whether the camera's picking that up. Tell you how these are connected up. But you will find that there's a spare terminal on each of these, and I have a terminal connector that I can put on the earth up there. And you'll also note that 3-phase cabling, here we go. So that was the earth. Sometimes it's yellow, sometimes it's green, sometimes it's green and yellow. And you'll notice that the colours here match up with those colours there, so that's how they're going to be connected, which is normal for a 3-phase unit. Right, so I've taken off the 3 connectors for the 3-phase, and this is a connector I've got for the earth. So what you simply do, I'll just show you one, because it's pretty repetitious. You don't take off too much of the insulation, just choose the right, pop that off there like that, twine it like that. Now I'm going to do a process called tinning, and also I'm going to use my little device that I've had for many years. It's a helping hand. Put that in there like that. Oop. Come on, helping hand. Now the soldering iron has been warming up for some time, so what you need to do is get a little bit of solder on your soldering iron. I'll zoom you in a little bit. Might be able to see a little bit better what's going on. So first of all, we need to get some solder inside this. So just heat it up. Okay, we've got some solder in there now. Then we get our wire. Alright, heat that up a little. Got some solder on here. It's called tinning, by the way. Just make sure you got solder on it. This is ready flux solder. Okay, so then heat this up. Pop it in there like that and release. And there you are, one soldered connection. So you just do that now on the 3 wires and we'll connect it up to the motor. Okay, so there they are, they're all soldered on and we're ready for connection. Fairly easy. I've just pulled the conduit back so I can put this on. So to get this on, put those through there first, like so. Then put these through here, like this. Will they all go through together? No, 3 will. Then the 4th. So they go through. Pull that up there out the way. So, very easy. Let's not tangle these wires up. It's nice to keep them nice and straight. That one on there. Let's get the nut. I'm not actually tightening them up yet because they're not going to stay like that. They're going to come in from this sort of angle, like that. Black next. The blue, like this. I didn't really like that idea. It's just an indication tag of earth. So I'm going to take that off, and I've put 2 little flat washers on here, which I'm going to screw in here to make a very, very good contact. Actually, what I need is a pair of pointy nose pliers to hold that there, because I want it to be in that exact position. Get that rubber up out the way. Slacking off a little bit. Pull that rubber up out the way. That's better. Tucks down there like that. Nice and firm. Because that's the area I've got there. That's where the inside edge of this comes. So I don't want to trap the wire in any way. Okay. So that's all fine. Now I can pull this up and just offer it up into here and make sure the wires are going to lie where I want them to. Yeah, that's fine. They're not fouling in any way with each other. So now that can be screwed back on. And this particular spindle has ceramic, 4 ceramic ball bearings, because I use mine to cut aluminium as well. Aluminium, brass, copper. It'll cut it, it'll machine it. I do see people trying to machine steel as well, mold steel. Wouldn't advise it. Okay, let's do this up now. When you do this up, it sort of clamps around the cable. It stops it pulling out. Let's get a little shifter a minute. Just enough so it does clamp on the cable like that, because this is plastic, and you know, this is plastic as well. You don't want to over tighten it and snap it off. Now I can put the, oh, this is the most difficult job, I think, getting this back on. There we go. Okay, so that now is ready for me to, I don't know whether, I don't think I'll put any insulation tape to connect this. There's no need to really connect it, because what I'm going to do is I'm going to put a bracket. You can't see, can you? Oh, that's better now, you can see. So I'm going to put some sort of bracket up here. Or I may just put some connected via something onto the back of here, and give this plenty of slack, you know, to move up and down and not get caught up anyway, which is fine. I may put a bit of insulation sealer on there just to connect it to that, but you know, just got to make sure there's plenty of cable, you know, for this motor to go up and down. And so really that is the spindle connected up at the motor. So now we will I might quickly actually pop a hole through there and put a zip tie there. Okay, and now a couple of zip ties over the back here. Stop this floating around and hold it in the right position. Okay, so I've just repeated the process down here at the VFD. Now the two, we've got something to point with. Okay, so the two earths, now this is the earth supply. Now this is the earth supply directly from the incoming mains, and this is the earth supply up to the VFD motor, which is the yellow lead, and here is the red, black and blue leads coming in. Now I don't know whether you can see that figure on there. Letter U is red. Now, I don't think you can see that in there, but the next one along is V. V is black and W is blue. Okay, now get in there a little bit closer. You might be able to see through from the side there. So that's U, V, W. Red, black, blue. Now that is the way that my VFD and my spindle is connected up. That's the way the wiring says in the book, and so it should be correct.